Alright, today we are going to be finding the velocity on our roller coaster on the top of our second hill halfway down our roller coaster. Right now I'm just drawing a very broad and brief picture of the roller coaster for you. The top point where we have the max potential energy in the start of our roller coaster is 1.9 meters high, and the point we are measuring is 0.65 meters high. Right now I'm writing out the equation for potential energy, mass times gravity times height. And then I'm plugging in the variables for that equation right now. 1.9 times which is the height, times the mass of 0.005 kilograms times 9.8. When you calculate that out, you get a potential energy of 0.0931 joules. Now on the other side, I'm now writing the equation for kinetic energy, which is half mass velocity squared, and that equation and the relationship between the two as described in the law of conservation of energy is what's going to allow me to calculate the velocity of the marble at specific points along the track. So right now I'm doing the exact same thing I did before, except I'm calculating it for the point at the hill instead of at the top. The reason I calculate both those potential energies is because at the top of our roller coaster, there is the max potential energy allowed and zero kinetic energy. And then at the hill, which I'm actually trying to find the velocity of, that has the that potential energy, finding the potential energy at that point, that gives me two different numbers, which I'm showing you now, and that allows me to subtract the two, and a loss in potential energy with no friction equals a gain in kinetic energy. So right now I calculated that out, and the kinetic energy at the top of the hill is 0.06125 joules. Right now I'm writing out the law of conservation of energy, which I just explained. It's very important to subtract the two potential energies along your path, because if you just calculate the potential energy at that point, that doesn't describe the kinetic energy. It just describes the potential energy that the marble has. You want to be actually finding the kinetic energy, which means you need to find out what the loss in potential energy is. Now I'm just going through and putting in the numbers. So I'm substituting in my loss of potential energy and putting that in as my kinetic energy, which it would be with no friction. And then I'm setting that equal to my equation for kinetic energy, half mass velocity squared. Right now I am calculating out that half of my mass is 0.0025 grams, dividing both sides to isolate velocity squared on both sides. These calculations are all made on the basis of no friction. That's pretty important. All right, right now, to get rid of the squared on the velocity, I am taking the square root of 24.5, which was my energy divided by my mass. And for my velocity at the top of the hill, I'm getting approximately 4.9497 meters a second, almost 5 meters a second. Now, while this may seem unrealistic, keep in mind that there's no friction along any point of this track, and my marble has gone considerably over a meter down on the track. Thank you.